So we're just walking through these slides, and given that we've had the lab now on Tuesday, a lot of what's in this set we sort of know about or we've practiced. Because if I pick up the story maybe from here. So essentially what we did in the lab is we practiced what's called the edit stage commit workflow, which is the basic workflow. And the other thing that I was harping on about the last day, and having practiced it now, perhaps it's a little bit clearer, hopefully, this idea of any particular file in your project working directory. At any point in time, its status could be any one of these four, as far as Git is concerned anyway. And again, just to refresh, if I've got a file in my working directory that I've just created, put some content into it, it has never been committed to the repository so far, then from Git's point of view, it classifies it as an untracked file. If I've got a file that I have already committed to the repository and I have made some edits to it in the working directory, sorry, if I've got a file, I've committed it to the repository and I have not made any changes to it since I committed it, then from Git's point of view, it's classified as unmodified. Thirdly, if I have made edits to a file that was previously committed, so in other words, Git knows about it, from Git's point of view, that file is now in a modified state. And then there's this odd one where what I'm saying is I have a file, I've modified it, I've told Git that I'm going to commit it, and I've done that via the git add command. At that stage, Git classifies it as being staged. So hopefully all of those kind of make sense. And I think I can kind of fast forward to here is where I left off. And we did this the last day as well. You know, if you're in the middle of doing development and you've made a number of edits and created a couple of files. So I'm saying here, for example, suppose we've modified file A and file A, B, and C and created file D. You don't have to stage all of them. You can be specific. You can just say, I'm only going to stage those two, which means if I've just staged those two, when I do a commit like this, notice in the commit, we don't specify what files were committed. We've already indicated that from the immediate preceding add. But the point anyway is you don't have to stage everything that is committable, right? So, you know, you can be specific. And you might do that if, you know, if the edits to file A and B, if they constitute a nice coherent unit of development, maybe the edits that you were doing in C and the file D that you were created have nothing to do with the work that you were doing in A and B, then it would, from a good practice point of view, we should stage A and B and commit them, and then maybe later on stage C and D and commit them. So that was that caveat. The commit message itself, the key point to take from this slide is what I'm saying here. When you're trying to come up with a meaningful message, and you should always try and come up with a meaningful message, then think about why did you make the changes that you've made to the particular files? And if you can answer that in a short, coherent kind of sentence, then that's the why you made the edits, and that's what should appear in your commit message. The main purpose of the commit message is it's a means of communication to other people that are working on the project that you're working on. So when they do a Git log and they see the commit messages, hopefully they can tell from the commit message what work was actually carried out and what work was committed to the repository. for that particular commit. If they want to know details, then they can explore which particular files were edited and where in the files were they edited. That's more the, that answers the kind of, the where did I put it? The what part, yeah. If they want to find out what was changed in the commit, then they can dig deeper and find that out. Git will help them to do that. But the commit message should express why did you make the edits that you made and committed. And try and think of that when you're coming up with a commit message. If you can't come up with a coherent statement as to the why, then maybe, you know, you've got a random set of edits that you've been doing and there's no coherence to them. When you're working in industry, a lot of software houses, they have a kind of a policy in terms of the commit messages. Maybe they have to follow a particular format. You can actually put the commit message, if you can't condense it into one kind of succinct sentence, maybe you need a paragraph to express it, then you can actually put the commit into a separate text file, and you can specify that text file in the commit command itself. We haven't done that, but you can do that. And as I said, the commit messages are all about communicating to the rest of the team that are working in the project as to what is associated with the commit. The idea of committing independent changes, that's kind of what I was getting at on the previous slide there, where I had changes to file A, B, C, and I created D, but it's the stuff that I did in A and B, those edits constituted something independent and coherent. So, you know, I should stage and commit A and B separately. That's what I mean by an independent changes. Okay. Next, this slide and the next one is all about the role of the .git ignore file, and hopefully everybody is clear on its purpose now. And it's very important to try and get into the habit of, before you do a git add and git commit, always check, do a git status first to check, what am I about to stage? And check, and if there are any files in the response that you get back from your git status command, then go into your git ignore and update the git ignore so that the particular files that you don't want to have staged are indeed ignored by Git. From a syntax point of view, the git ignore is just a basic text file. And as I mentioned in the lab, the only mistake that you might make is if you tab a particular line, if there are spaces at the beginning of the line, then effectively the line is ignored. And the final thing I'll say about it is, if by accident something gets into the Git repository that shouldn't be in there, let's take the extreme example of the node modules folder. Once the folder and the content is gone into the Git repository, it's essentially no use updating the git ignore after that. Once they're in, and you can never really get them removed. So that's why I'm saying, just be careful, do your git status, get into the habit of doing a git status before you start git adding and git committing. There is what's called a limited amount of regular expression syntax that you can use in the lines in the git ignore file. The one that's most often used is the wildcard character, the star symbol. But there are other ones as well. I don't know if you're familiar with this, what's called regular expressions. Okay, it's a syntax, it's a generic syntax associated with programming mainly. I'm not going to go into it here now, but you can look it up yourselves if you wish. But as I said, you tend to only ever use the star sign in your git ignore if you want to have some sort of variation in a particular line. And of course, the importance of the slash at the beginning of the line. If you have a slash at the beginning of the line, then you're essentially referring to a folder that you want to have ignored, as in the /node modules, which you've seen. If you're ever in doubt, then always just do a Google search. You know, if you know there's a particular folder or file or set of files that shouldn't be included, and rather than specifying them individually in the git ignore, then try and use some of these regular expression syntaxes to help you to condense it into one line. Okay, that's just an example which you can read through yourselves. The Git Diff command shows you the differences between a file, and there's lots of variations on it, and really you can read this kind of stuff yourselves. You know, typically the things you might want to do is, what's the difference between the modified state of a file in my working directory and the last commit that I did of that file. And you know, there's one variation of the Git Diff command that does that. Or if you want to find the difference between two commits for a particular file, then yeah, there's a variation on that. Now, you know, you can do these things from the command line, but VS Code just does an awful lot for you. It has excellent built-in support, as you've seen the last day. So I'm not going to go through examples of these individually. I'm just documenting them for you. Similarly, the Git log gives you a log of all of the commits, but there's lots of options, I'm saying, as well on that. You know, if you're working a project, or if there's a team of people working a project over a long period of time, let's say a year, then you could have a couple of hundred commits done to the repository. So maybe you're only interested in a subset of those. Maybe you only want to see the last 10, or you only want to see the commits that were made during the month of July, or various other options. And the Git log command has command line options that allow you to express that. For example, the -stat option on the Git log, not only does it tell you who made the commit and when, it will specify the actual files that were changed. But of course, now that you're familiar with using Git inside in VS Code, we wouldn't tend to do this from the command line. We'd actually do it from within VS Code. And if I just quickly flip over, I think I demonstrated this the last day, but so here's my catalog. And if I go into Git and bring up the full log, and if I click on any one of the commits, let's say I click on this one, down here it tells me what files were changed in that commit, and some sort of indication as to the volume of change. If I want to find out what change happened to this particular file compared to the previous one, then I go over here. You know, so it's really nice and visual. So it's telling me I added this to the file, and I seem to have remove something here, etc., etc. So we tend to use the command line less so with Git when we've got a nice UI interface to it, as we do there. Yeah, various options, you know, with the Git log. If you do it from the command line, you obviously have more power from the command line. So something like this, for example, I'm only interested in the Git commits that were done after a particular date. So it's really nice and expressive, the syntax. But again, you can read up on that if you need to. It's unlikely that you will in this module anyway. So in summary, we talked about centralized versus distributed version control systems. Git follows the distributed model. It's all about the repository versus the working directory or working area. Hopefully you're clear now on what I mean by the working area. The initial startup, you know, you create your Git repository, you stage all your files and you commit all of them. That's your starting point. The role of the Git ignore, the basic workflow, which you did in the lab the last day, the whole notion of a file status, which we talked about at the beginning of today's lecture, and the role of the commit messages. Right, so that's kind of the 101 stuff. What I want to cover next, and you will get these slides if I go back to Moodle, the slides I'm about to go through next, you will find here. And what I'm going to cover in this set of slides, you typically wouldn't see this material covered in any articles that you read about Git, but I think it's really nice to know how does Git actually work internally, and it gives you a more comfortable working with it as a result of that knowledge. So I'm looking at the Git's internal, what I'm calling its internal data model, because essentially Git is, it's a database. It's not a relational database, but it's just storing data, the data being your files and folders and the structure and the evolution of those files and folders over time. So from Git's point of view, when you commit stuff into the repository, what Git will do is it computes a checksum of each file, and it actually stores the contents of that file somewhere inside the repository. We'll see in a while where exactly it puts them. But the physical file, its name will be based on the checksum that it has computed from the file's content. Okay, so it takes the file, it looks at the content of it, it computes a checksum of the content. A checksum is essentially a long string like this. Okay, the algorithm it uses to compute it is the SHA-1 algorithm, which you may have come across in security. So internally, what you will find is loads of physical files whose name looks like this. The contents of those files will be the contents of your files. And that's essentially kind of what it does behind the scenes. Of course, the nice thing about a file having a name like this, and that name is derived from the content of the file, it means that you cannot go into the repository, make some change to the file, because now the contents of the file is not consistent with the SHA-1 hash. And straight away, Git will spot this and it will realize that your repository is corrupted. So that's what I mean by data integrity here. This is how it guarantees the integrity of the data in your repository. Any internally and any references to physical files, it uses the actual checksum as the reference. And we'll see that as well in a moment. So it uses the SHA-1 algorithm to compute these checksums. The checksum, a SHA-1 checksum is a 40-character string, hexadecimal string. And it actually does the same for directories, as we'll see. So that's its kind of data integrity. So if we actually dug into a Git repository, then the key folder where it puts all of the data, if you like, is this objects folder. And here I've just expanded some contents from a repository that I have. And so here's a physical file. And this represents potentially anyway, one of my files from my project. Now, if you actually counted the number of characters here, you'd see that there is actually only 38. So what it actually does is when it computes the checksum for a file, it takes the first 2 characters of that checksum and it creates a folder inside in this objects folder. It creates a folder made up of the first 2 characters of the checksum, and then it creates a physical file that contains the remaining 38 characters. And the contents of that file then is whatever it corresponds to from your working directory. So it's inside in this objects folder, inside in the Git repository. That's where it stores all of the data. And we now have some inkling as to how that appears as a file and folder structure within the repository. I'm just showing you an example of it here. And the folder structure doesn't get any deeper than this. You won't have folders within folders within folders. It's only one level deep. Now, internally in Git, it refers to objects. That's what it stores. So as far as Git is concerned, there are 3 types of objects. It doesn't really talk about files and folders as such, even though objects do correspond to files and folders, but it's internally, it talks the language of objects. And so there are 3 types of objects, I'm saying, that are stored inside in a Git repository. In other words, stored inside here. 3 types of objects: blob objects, and a blob object will correspond to a normal file that you would understand from your working directory. So our catalog.js file, that would be stored as a blob object in the repository. It has 3 objects, and a tree object will correspond to a directory from your repository. So our src folder would be represented as a tree object in the repository. And thirdly, a commit object. And a commit object is created every time you perform a git commit command. So there are the 3 types of objects. So if I go back to the previous screen, we can't really tell from looking at this here as to whether this here corresponds to a tree or a blob or a commit object. We can't tell from the name, but there is a way of finding out, as we'll see. And the way we find out is this special command called the Git Cat File Command. And this command allows you to essentially explore the objects inside in the repository and find out what does an object represent and what is its content. And it has 2 command line options. Right, so I'm building up now to giving you a demonstration, so it's all a bit wordy for the moment. Let's take it from the top, right? So when we perform a staging, sorry, what am I saying? Git performs the following steps during, oh yeah. When we perform a staging operation, in other words, doing a git add, what Git does is it finds all of the files in your working directory that have been modified or are new, in other words, untracked. It computes the checksum for each of those files, and it actually puts an object into the repository for each of those files. And it also, internally, it also updates a special file called the index file, which we won't go near, but inside in the index file, it has a record of the new objects that have actually been put into the repository. And the new objects that have been put in will correspond to the untracked, sorry, the untracked or modified files that you have just staged. So let's see this in action. So what I've done is I've created a very simple little folder here. Okay, it has a subdirectory and a file, and inside the subdirectory, there's another file. Okay, there's no Git repository so far. So I'm going to import that into VS Code. I've got a git ignore as well. This now does not have any repository at the moment, and to prove that to you, if I do a dir, sorry, ls in the case of ls-a gives me the full content of the directory. So if there's no .git, you can see here, there's no .git folder. So let's create a repository. Now I'll do it the easy way. I'll get VS Code to help me. So I go in here and I click this. That has now created an empty Git repository, and I can prove that to you out here. If I go into the demo folder and if I display my hidden files, I don't need to, you can see it there already. There's my Git repository. And if I drill down into it and show it to you this way, we can see inside in objects, these are just 2 standard folders. So at the moment, there are no objects in my repository. These are just, as I say, just two default folders that are always a part of the objects. The next thing I'm going to do is I'm going to stage everything. And it's telling me that these files here, these three files, are ready to be staged essentially. Okay, they're all untracked, obviously, because I haven't committed anything to the repository yet. Let's be clear now on my structure. Okay, so I've got a git ignore, I've got a file1 up in the base folder, and inside in a dir1 subfolder, I've got a file called file2. If I look at the contents of file2, that's all it contains. If I look at the contents of file1, that's all it contains. And my git ignore just contains that. These DS files are just a Mac. They're Mac file system management files that I don't want to put into my repository. But other than that, it's just a standard git ignore. So I am going to stage everything. Now I'll do it from within VS Code because it's easier. I could do it from the command line by just doing git add -a, but this is how you do a staging in VS Code. You can essentially stage individual files by clicking the plus beside the file, or if you click the plus here, it has now staged everything. And it's kind of telling you this. Everything here now is a staged file. So the files have actually already gone into the repository. And to prove that, if I go back to here we can see them. There are three objects gone into my repository already. So when you do a staging, you are actually already putting the stuff into the repository. I can unstage just to, I can actually unstage everything. I can take them all out again if I decide, oops, I don't want all those to go in. This is an easy way to do it in VS Code. There's a command as well, but if I hit the minus sign there, it's going to take everything out. So I've unstaged everything, and hopefully if I go back to my repository, well, I knew I shouldn't have done that now, but it has actually, what it has actually done now is, let's just be clear on, I'm going to go back, go in again, and look at it. Yeah, okay. They are still physically here, but what it has done as a result of my unstaging is it has made edits to this index file to indicate that the files have been unstaged. So just accept that for now, okay? We don't do unstaging that often, and really, I shouldn't really have done it there with you right now. But anyway, just maybe I'll cut that from the video. Let's go back to the normal process. I've staged my three files. Hopefully, I haven't corrupted. They are not corrupted, but no. Okay, so they're still here. Here are my objects. Now, I wonder which object does this correspond to? So this is where the Git Cat File command comes in. So if I use the Git Cat file, and I don't have to specify the full hash of the file, just the first 3 or 4 characters will do. So I've got here 0A7A. So if I use this Git Cat file, so the Git Cat file is a command that allows you to ask Git, tell me something about a particular object. Now there's 2 things you ask it. What type of object is it? That's the -T option. And can you predict what type of object this is going to be? Is it going to be a blob, a tree, or a commit? My guess is it's going to be a blob. And it says fatal because Git Cat file -T. Did I give it the wrong? Just 1 sec now. Sorry, what didn't do that? Doesn't like the, just used the wrong hash, I think. 2A, sorry, 0A. Okay. Tells me it's a blob, and I wonder which of the blobs is it. And if I display the contents of it, it looks like it's file 1. So that is the contents of file 1, which I showed you a moment ago. Okay, so it looks like this blob object here corresponds to file 1. This is either file 2 or git ignore. This is either file 2 or git ignore, and you could prove that in a similar fashion. So staging involves putting the modified or untracked files into the repository. And I've just proven that to you. The next question is, what happens when we do a commit? And the answer is, it knows now what files have been staged because it has actually recorded it in this special file. There's no point in us looking at this file using an ordinary text editor because it has special kind of non-printable characters that just doesn't make any sense. So we're going to ignore that, but it knows what new files have gone into the repository. Because obviously, you know, when you're doing a git add later on in the project, there will already be objects in there and it's going to be adding some more objects. So it does need to record what are the new objects that have gone in. And also in here, it will record where those objects, the files that they correspond to, what directories were they in. Okay, and when it does a commit, it now actually computes a hash value, I'm saying, for each directory associated with a staged file. Okay, so in our case, it would compute a hash value for my dir, what did I call it? The dir1. It would compute a hash for the dir1, and it would compute a hash for the actual base folder itself, which I call demo. So it computes a hash for those two directories, and it stores those directories as 3 objects in my repository. And thirdly, it stores another object corresponding to the actual commit itself. So let's do a commit. So I would expect now when I do a commit, I would expect 3 more objects to be put into my repository. One of them will correspond to the actual commit itself, and the other 2 will correspond to the 2 directories that make up my project. So let's do that. And I'll do it the easy way from within VS Code. And this is how I commit, by just clicking this. If I now flip back to, we can see that there are more objects now actually gone in. And indeed, there's 1, 2, 3, 4, 5, 6, which does match up. I had 3, and 3 more have been added. Now, what I can do now is let's look at the commit object and the 3 objects. What do they look like? Because certainly the 3 objects should reflect the directory structure of my working area. So what I need to do is I need to find the hash of the commit, and the easiest way to do that is as follows. So here's the actual hash of the commit. So if I do a copy of that and I use my Git Cat File Command, if I do a -t first of that hash, can you predict what type of object it's going to be? Is it going to be a blob, a tree, or a commit? It's going to be a commit. If I want to see the contents of that commit object, it's actually, the kind of stuff that we see up here. Who made the commit? When was it made? What was the commit message? Critically, this line here is really important. This is telling me the hash of the tree object, the directory, in other words, corresponding to my base folder. So there is going to be an object in my repository that has this as its hash value, and that object is going to correspond to the base folder of my project. So if I grab part of that hash and I do a git cat file -t on that, indeed it is a tree object. If I do a -p on it, it's telling me that that's the content of that tree object. And of course, that corresponds to, if we look over here, what's stored inside in this tree object is the hashes of the other objects that are linked to that tree. In other words, the contents of the base folder of my project. And it's actually giving me the names that I am using in my directory, in my working directory, for those various files and folders. These are here for my purpose, but internally it uses these hashes. So these correspond to other hashes. Sorry, these correspond to other objects in my repository. And I can keep drilling down. So supposing I take this one here, which corresponds to the dir1 folder in my working directory. If I ask Git, what is the contents of that tree? And surprise, surprise, it's the actual contents of my dir1 folder. My dir1 folder indeed does contain a single file called file2, and that file's corresponding object has a hash of that. And if I did a git cat file on that, I would get the contents of file2. So internally within Git, it stores these different blob, tree, and commit objects, and they represent the status of our working directory when we did the commit, when we performed the commit. And the tree objects allow us to navigate from, it allows us to navigate through essentially this network of objects that Git creates. If you can visualize it, I have a commit object at the top that's pointing at a tree object. The tree object then is either pointing at blob objects or other tree objects, depending on what the structure of your working area is. And so that's how it represents your working area internally within the repository. And you can, I've tried to demonstrate there, navigating through these objects and to confirm that they are actually a reflection or a snapshot of my working directory when I made the commit. So we're going to do this in the lab next week. So that's all about the internals of Git and how it actually, A, how it stores your data, and B, how it guarantees the integrity of that data. And this Git Cat file is really useful as an interface into accessing those objects. Now, where am I? Okay, on time. Right. So as I said, hopefully the lab will clarify that for you next week. Just going back, and I'm just going to move on to the next part of our discussion on Git, which is all about branching. So you can grab these slides later on. Branching is something we haven't done so far, but as a kind of a professional developer, you're always going to be using branches. So what are branches? I'm saying they're divergences away from what I'm just calling the main line of your project's evolution. So in the labs, what you were doing last week was you'd do an initial commit, then you'd do some edits, you do another commit, stage and a commit, more edits, stage and commit, etc., etc. So you were doing a series of commits. Now, when you create a repository is made up of branches, and initially there is one branch called the master branch. So what we would now say is that when we were committing in the lab last week, we were always committing to the master branch, or the main line of development. But quite often what you want to do is you want to do some development, but you don't want to commit it to the master branch. Later on, you may decide to integrate it back into the master branch, but initially you don't want to do that. So these are the different scenarios where, you want to maybe develop a new feature for your app. And the first thing you should do is create a new branch and do your commits onto that branch, and then do your testing, etc. And if you're happy with the feature, what you would then do is, as we say, merge the contents of that branch that you created, merge it back into the master. We'll see how we do that. Or if you just want to do some refactoring of code, create a new branch as your starting point, carry out your refactoring, run your tests, make sure everything is okay. And then if you're happy with it, merge it back into the master. So we're always, similarly, if you're doing debugging or if you're just doing experimental work, really, no matter what type of work that you're doing, what you should try and ensure is that you create a branch first, and you do your commits in the normal way. And then eventually when you're finished doing that work, you have the decision to make, do I want to merge this work back into the master or not? So that should really be your kind of modus operandi when you're doing kind of proper development, and hopefully even as an undergraduate. So instead of the edit, stage, commit workflow, this is the workflow that any kind of professional developer would follow: the branch, edit, merge. What's kind of advised is that when you're doing a commit, you should never really commit to the master branch. Git won't stop you from doing that, but as a good practitioner, you should always avoid committing to the master branch. The only operation you should carry out on the master branch is to merge another branch into the master, and we'll see how we do that. When you're doing commits, you should be on some other branch, and we'll see how you switch your focus away from the master branch to another branch. It's just a command, essentially. So this is the workflow that's more commonly used by developers. Now, physically, what is a branch? I've just been talking about objects and all of that, internals within Git. So what I'm trying to show you here in terms of visual, supposing I've done 3 commits, and for now we are actually committing to the master branch because we don't know how to create other branches yet. So the visual that I'm showing you here is I have carried out 3 commits to my master branch, and each of the commits is referring to a network of tree and blob objects. And I've tried to illustrate that a few moments ago. So each of these snapshots, as they're called, is representing a little network of tree and blob objects. And we know now that each of these snapshots is a mirror of the status of your working directory when you carried out the commit. What we'll see as well in the lab next week is that obviously between this commit and this commit, which I didn't mention a moment ago, but between these 2 commits, there may be files that have not changed at all. So what you would have in that case is inside in this snapshot, you would have a reference within a tree blob referring back, within a tree object, referring back to a blob object from an earlier commit. So that's obviously good from a data storage point of view in terms of the volume of storage each of these snapshots consumes. But for now anyway, so this is a series of commits to a particular repository. And when we talk about branches, where do branches come into this, or how are branches represented within a repository? And really, I'm saying down here that all a branch is a simple movable pointer to a commit object. So we'll see in a while actually that a branch, it is a physical file. The name of the file corresponds to the name of the branch, and it's up to you to decide what names to give to branches other than the master one. You can't control that. But if we looked at the internal content of a branch file, then what it would contain is a single line, and that single line would be the SHA-1 hash of the last commit that was made to that branch. In fact, if I go back to our little case study, I've documented in a while, but I can tell you that the branches as physical files, they're stored down here. Now, my repository, the only branch that I had is the default one, the master one. So that's a physical file referring to or relating to the master branch. And if I view the contents of it, just using in my case this, that is the SHA-1 hash of the last commit that I made to the master. And so it's C22 something. So if I go back to my objects, can I find one? Here it is here. Okay, so branches are much simpler than objects. They're just files that contain the hash of a commit object. So the master branch initially, I've already said that every repository has to have a master branch. And every commit, every time you do a commit, all that happens to the branch file is it just changes the hash value that's stored in that file. So the branch file will only ever have one line in it, and that, as we now know, will always be the hash of the most recent commit that was made to that branch. So every commit moves the master pointer forward. That's fine. The caveat is here, but we don't know how to do this yet. So this is my visual representation. Okay, so this is my branch file, and as I've shown to you, it just contains a reference to the most recent commit. That's how it's stored internally. The working directory is always aligned to some branch, and for now, because we don't know how to create other branches, the working directory is always going to be aligned to the master branch. And if you noticed, when you type the git status command, it essentially confirms that. It's telling you that the working directory is, as it says, on the master branch. What that kind of means is, the consequence of that is, if I do a commit, then the commit is going to be to the master branch, and the master branch file is going to be updated. Okay, this is how Git knows to which branch a commit is linked to. Okay, so it knows that when you go to do a commit, you don't have to tell it which branch you're committing to. You're always committing to the branch that's currently aligned with the working directory. And we'll see in a while how you can actually change it so that when you do git status, you're told that you're on another branch. I've kind of already proven this, G. So branches are physically, they're just files that look like that. So we've kind of already covered that. This is where you find them buried within the repository itself. So dig down into this sub folder, as we see on the right there. And I'll just leave it at this, I suppose. How do I create a branch? Very simple command, git branch, and whatever name you want to give to that branch. And once you submit that command, it essentially creates a new physical file in that heads folder. And the new branch, which I'm representing like this down here now, it's going to be pointing at the same commit that the master branch is pointing at as well. Initially, anyway, the new branch is going to be pointing at the same commit object. Right. So what we need to cover in the next lecture is, well, how do I change my working directory so that it's now aligned with this new branch rather than the master one? And then how do I merge the contents of that new branch back into the master? These are the kind of practices and actions that we need to know how to carry out. So I'm going to halt it there, and I didn't give you an opportunity to ask any questions, but those kind of things arise in the labs. I think they're better dealt with there.